Hi, today's lesson is about reflecting graphs of functions. Really all that means is reflecting over the x-axis and the y-axis. If we take a look at the get started, they're asking us to write the coordinates of each of those points A, B, C, and D. We're just going to do A, and I already wrote it out. A is -4, 3. And the first part says reflect each point in the x-axis. So here is the x-axis here, and if we're going to reflect it, one way to think of this is think of this A point as like a wet blob of ink or something, and then we fold the piece of paper along that x-axis. Where would it make a mark over here? So clearly if we count, like it's 1, 2, 3 away from here, so if we go 1, 2, 3, it's going to make a spot right there, won't it? So this will be our new spot. So instead of calling it A, let's call it A prime. I'll put a little apostrophe symbol there, so it'll be A prime. And what are the coordinates? What's the x and the y? Well, the x stayed the same, didn't it? Still -4. And the y value now is -3. So you'll notice now when we reflect over the x-axis, what happened? The x value stayed the same, and the y value got multiplied by -1. And I think that's important enough for us to write down. So when we reflect over the x-axis, what does that really do? What does that mean? We multiply the y values by -1. And I'm going to give you another way of looking at it. It may not make sense yet, but hopefully soon it will. We can write this as y is equal to negative of f of x. So I'm just going to leave you hanging there about what that means. Now I'm going to switch to green. We're going to do the second part. Now it says reflect each point in the y-axis. So here is the y-axis. I'll do this one in green. So we're going to reflect over there. And again, imagine that this is like a wet blob of ink, and we're going to fold along the green line now. So we are 1, 2, 3, 4 away from that green line. So 1, 2, 3, we'll end up over here. Okay? And I'll label that one as A prime prime, just to keep track of it. So A prime prime. What will the coordinates of that spot be? Well, my x value is now a +4, and my y value stays the same at 3. So I can say I'll do a similar note here. Instead of reflect over the x-axis, now I'll say, how about when we reflect over the y-axis? And so what do? We multiply the x values by -1. And my short form of that is y is equal to f of -x. Okay, so maybe we'll be referring to that in a little while. If I scroll down to the bottom, it's asking us to reflect this y is equal to 2x plus 3. So here we have a function, y is equal to 2x plus 3, and they would like us to, am I going to get this? They would like us to reflect not just points, but a whole line here. So we're going to reflect this first over the x-axis. So I'll try to keep track of this over the x-axis, and we'll reflect over the y-axis. Okay, so reflecting over the x-axis, here's the x-axis. You know, it's a lot easier to pick a couple points. So let's pick this point here, and maybe this point here. So when we reflect over the x-axis, again, if we do that fold, it's going to end up being 1, 2, 3. So 1, 2, it'll be over here, won't it? And this spot here, 1, 2, 3, 1, 2, it'll be over here. And then we'll get a line. Now I got to make a line. Having troubles. Okay, I got to make a line that goes through there, so let's see how I do. Something like that. Okay, so that's my attempt at drawing the reflection over the x-axis. Now you'll remember, if we're thinking about this as multiplying the y values by -1, this spot here that I did earlier, that x value is 0, right? And that y value was 1, 2, 3. The corresponding point down here would be 0, comma, negative 3. So you see how that makes sense. Let's look at that other definition I had that I said, okay, y is equal to the negative of f of x. What does that really mean? Well, there's more than one way to talk about this function. Here they define it as y is equal to 2x plus 3, all right? And they graphed this as the x and this is the y. And you'll notice sometimes instead of writing y on the y-axis, they'll actually write f of x. Okay, so another way to think of this is to say that my y is the same thing as f of x. So if I were to say, hey, I need to multiply all my y values by negative 1, like that's what I'm doing on my x-axis. I'm keeping the x as 0, but my y becomes negative 3. I could go and say, okay, multiply all the y values by negative 1, so then I would get a negative here, or another way is writing a negative here. But if I'm graphing this, I don't want to graph negative y, I want to graph y on the y-axis, so I'm going to multiply both sides by negative 1, so y is equal to negative of f of x. Okay, or if I was to take the original definition, it would be y is equal to a negative, and I'll put brackets around that whole function, that 2x plus 3. So if my original function was y is equal to 2x plus 3, when I reflect it over the x-axis, I multiply all the y values by negative 1, and it becomes now y is equal to negative left parentheses 2x plus 3. And you could even, you know, for you math lovers out there, simplify that out, multiply out, get 2x minus 3. So this is, I know I'm jumping ahead in the lesson, but I'm just kind of giving you the good stuff right away. Let's go and take a look at the second part of this question, is if we are going to reflect this over the y-axis. So a reminder for the y-axis is that we're going to take our spots and keep the y values the same, but multiply by the x by negative 1, or it looked like this, f of negative x. So let's look at this first point, 0, comma 3. You know, it's getting kind of messy, so instead of writing on that, I'm going to switch over to my graphing software. So I've got 2x plus 3 is my original one. See if I can find it. Okay, I'm going to change this to get it 2x plus, here, I'll make some changes. I'll change this to 2x plus 3. Okay, and I'll get rid of some of these points that I made. Okay, so first of all, reflecting over the x-axis means multiply y by negative 1. So here is the way I defined it before, and you'll see this is what we got just a second ago. Okay, I'm going to get rid of that because I don't need to show it. Now I need to reflect over the y-axis, which means multiplying the x values by negative 1. So I've got one value here of 0, comma 3. So if I'm going to multiply the x values by negative 1, I'm still going to get that same point, aren't I? Because the x gets multiplied by negative 1, or the 0 gets multiplied by negative 1, and it's still 0, and the 3 stays the same. So one good hint is that it's going to go through that point. Let's find another point here. So here's another point. Oh, there's a better one. That looks like negative... Oh, where's a nice spot? Here's a good one. So this is negative 4, comma negative 5. Here, I'll just define this point. Just show it so it shows up. Now, if I'm going to say to reflect over the y-axis means multiplying the x values by negative 1, now I'm going to get 4, comma negative 5. And so when I make that point, 4, comma negative 5, it's over here, and I'll pop it on so it gets labeled. So now our reflection should be going through this point and through that point when it gets reflected over the y-axis. So again, if you think of this as a kind of a wet ink line and we're folding over along the y-axis, you can see how we're going to generally get that shape, and I'll highlight it there, and there we get it. So you see how that works about multiplying. If you want to reflect over the x-axis, it means you multiply the y values by negative 1. If you want to reflect over the y-axis, it means you multiply the x values by negative 1. And here is the kind of quick notation for showing that. Okay, let's go back to our other sheet here. Okay. So going on to the next page here, let's see if we can kind of sketch these out really quickly, what they're going to look like. So we need to reflect over the x-axis, and then we'll do a quick sketch of what that'll look like, and reflect over the y-axis and do a quick sketch to see what that will look like. So reflect over the x-axis. Here is our x-axis. So when we reflect there, again, these points are going to stay the same, right? Imagine that folding. This point is 1, 2, 3, 4 away. 1, 2, 3, 4. It's going to be up there. And we're going to get this kind of a shape like that, right? So I'm going to cheat just by drawing that over to here. So that's what it looks like when I reflect it over the x-axis, right? Now to reflect over the y-axis, and I think it might be good to switch to another color to do green over the y-axis. So here's the y-axis. The point that goes through the y-axis looks like about there is going to stay the same. The other ones are going to get flipped over here. So this is 1 away. I'll put a green dot over there. This one looks like it's 1, 2, 3 away. So over here. So this is approximately what it looks like when we reflect over the y-axis. Now let's just haul this over and put this over. So this is what it looks like. Okay. And again, I moved them, so you can't really give them in relationship to the original one. Let's go back to the graphing calculator and let's plug in that x squared minus 6x plus 5 and just see how it looks. There it is. So I'll go back to my original one. X squared minus 6x plus 5. And so I'll get rid of these points here. And we can see the two. Okay, so here is the reflecting over the x-axis, very similar to what we did, and here is reflecting over the y-axis. Looks great. Okay, and I think we can do this next one kind of quick. So I guess I should switch back to blue to be consistent. So if I'm going to reflect over the x-axis over here, here's my x-axis. Okay, so when I reflect, let's pick a few points. First of all, the ones right on the x-axis are going to stay the same, aren't they? Because we're really multiplying 0 by -1 and still getting a 0. This spot here is going to go up a little bit. This one's going to go straight down. So we're going to get this kind of a shape up and then back down again. And it looks like it crosses at 4. So now the reflection crosses at -4, comes out to around 6, goes like this, and then vertically like that. And I'll actually put arrows at the end of that. So that's what my reflection over the x-axis is going to look like. I'll just move it out of the way so it doesn't look so messy for drawing the y. But this is where it sits. Now let's try in green, reflecting over the y-axis. So here's my y-axis. Oh, better. Yeah, it is blue now. That's good. Okay, so going over my y-axis. This spot here is going to end up right there, and the ones that are on the y-axis stay the same, so that will stay the same. This spot, let's see if I can make this shape. Try again. It's going to go up through there. This part reflects there, and then it comes back down again. Kind of goes like this on the y-axis, and unfortunately this is kind of messy, so I will move. Let me just start over here. Reflecting over the y-axis, so this point will be there, this point will be there. These 2 points are going to end up over here, and this one will end up over there. So it's got this kind of a shape. And then this part gets reflected over here. So it's a little confusing because they're right on top of each other. But I think you might be able to get the sense of it. Now when I move it over, because I drew it in more than one, it didn't work out that nicely. So that's the way it looks like when it reflects over the y-axis. And that one does look a little confusing. Let's take a look at our first example. Actually, that gray area, this is giving the definition that I already gave you. I think they give it in more words, however. For this function, the graph of y is equal to the negative f of x is the graph of the original function after reflection over the x-axis. And here's the other way of saying it. The graph of y is equal to f of negative x, so you're multiplying the x's by -1, so it's a reflection in the y-axis. So this is the same notes I gave you before, but I'm thinking it looks a little bit harder to to comprehend. So first example, kind of a warm-up one. They give you 1, 2, 3, 4 dots that are connected. And so what you can do is you can take a look at each one of the dots. Okay, so you can even label this one. This is -2, 1. And we're supposed to graph this over the x-axis. So when I think, oh, x-axis, I'm going to multiply the y values times -1. Okay, so my x value stays the same. It's still -2, but my y value gets multiplied by -1. So my new function is going to end up, the first dot would be right here. Okay, and again, you can just think of this. So you're folding it over this line, so this one comes here, that one's going to come there. If we do the rest of the dots and then connect them, we get that shape. One thing I want to mention down the bottom is that they do state the domain and the range of each function. So just see how they state the domain. The domain is, if you look at it, can be all the values of x are within -2 and 6, and it includes -2 and it includes 6, right? Because it's that solid 0, not, or solid dot, not the whole. So it's -2 is less than or equal to x, which is less than or equal to 6, is the easiest way to write it. And the same thing for the range, right? If you're looking at the range of y values, is going to be between -2 and 4, and that's how they write this. Now for the reflections, -4 and 2. There's the check your understanding. I'm going to pause here because we're giving the announcements. I'm going to ask you to do the check your understanding, and then when I come back, I'll show you the answers.